So ठीक है, let's start with this one. ठीक है, remember ये कौन सा है? This is October November 2017 2-3. अच्छा, अब starting with the first question. Okay, the first question is what is meant by the term bond energy. ठीक है, so एक second. अच्छा, so what's bond energy? Bond energy is the energy that is needed. It's an endothermic process to break a bond, basically, but to break 1 mole of bonds. So it's the energy that is needed to break 1 mole of bonds of the same type. Really, if you're trying to break this N triple bond N, you're basically trying to break 1 mole of these bonds. So bonds are of the same type in gaseous substances. So that's very important कि gaseous substances होने चाहिए. So they're going to be broken in gaseous substances. And remember, bond energies are not going to be applied if the substance is a liquid, because there would be other intermolecular forces present as well. Achha, then you have used the data to calculate a value for the NH bond energy. How do you calculate enthalpy change for a reaction? You basically figure out the bonds that are broken. Now that part is endothermic. It requires energy, and then bonds formed. And that part is exothermic, which is why it has a negative sign. In this question, the enthalpy change is already provided, so it's minus 92. And how many bonds are broken? So if you look over here, there's an N triple bond N that's being broken. How much energy that's required? That's 944. And there's only one of them that's being broken. Then you have to break the H2 bond. So that's 3 H2 bonds, and the value is provided over here. That's 436. So that's 3 multiplied by 436. All of this is going to be positive. And then bonds formed. How many bonds are being formed? So that's 2 NH3 molecules. If you look at an NH3 molecule, it has 3 NH bonds. And since there are 2 of them, you're basically trying to make 6 NH bonds. And that's exothermic. So इसलिए the sign is going to be negative. Make NH the subject of the equation. Can anyone try and do the calculation? It's going to be minus 92 minus 944 minus 3 times 436. ठीक है, 3 times 436. The whole thing would become positive because and then you're going to divide by 6. So can you try and tell me what the answer is? Hibareta, Zahid, what's the answer? So the answer that you're getting is 390.7 kilojoules per mole. You must show your working. So you've shown your working, and everything is there. Now the next part is, and remember, always show your working very neatly. But even it would be better if you had written this as well. You can make it a habit. Just don't try and find the answer. Try and find the answer in a neat way. Write this, then write this, then. I mean, this is not required, but it's better if you write this down as well. So then you have the Boltzmann distribution, and he's asking use the same axis, sketch a second curve to indicate a Boltzmann distribution that is at a higher temperature. So higher temperature पे क्या होता है? This is the high energy side. So at higher temperatures, you have more molecules having energy that is at high energy. You have the the height is the number of particles. So you have more particles at higher energy, and you have fewer particles at lower energy. So the graph is going to get skewed to the right. Okay, that's the graph. This is the average energy point. Maximum number of particles are around the average energy. But since now the overall temperature is higher, So the average energy point is also shifting towards the higher energy side. Okay, so you have more particles now at a higher average energy. अच्छा उसके बाद with reference to the Boltzmann distribution, state and explain the effect of increasing temperature on the rate of production of ammonia. So, and remember, it's not a question on equilibrium; it's a question on rate. Okay, so you just have to talk about rate. So what they've given you is the activation energy, which is somewhere over here. Okay, this is the line of activation energy. So, pehle the number of particles having energy that is greater than activation energy, that was very few. But now the number of particles having energy that is greater than activation energy, because you have more particles now at higher energy. So the curve is much higher now. So the number of particles having energy that is greater than activation energy increases. So for 3 marks, this is what you're going to write, that you have to use with reference to the Boltzmann distribution. So the curve rises, yeah, it shifts to the right. Actually, it shifts. 1 second. To the right. So number of particles having energy greater than activation energy. As a number of particles having energy greater than activation energy uh, increases. So you have more successful collisions now. So that's the explanation. And then state and the effect of increasing temperature on the yield of ammonia. Now this is never confuse the rate with the equilibrium. So now he's basically talking about the yield of ammonia, which is basically the forward and backward reaction, which is going to be favored. So if you look at the question, so since it's an exothermic reaction, exothermic reactions are not favored at higher temperatures. So the equilibrium is going to shift to the left and the yield would drop. So it's an exothermic reaction. Higher temperature favors, so it's a 3 mark question, so you have to give the explanation as well. Higher temperature favors endothermic reaction, which is the backward reaction. And equilibrium position shifts to the left. So next is at a pressure of 2 into 10 plus 7, 1 mole of nitrogen was mixed with 3 moles of hydrogen. So, and the final, so this is about this question I think is about Kp. So you're going to make the table where N2 and H2 are reacting, and then in equilibrium with 2 and H3. So what's the initial situation? So initially, what you have is that there's 1 mole of nitrogen, so that's 1 mole, and then 3 moles of hydrogen, and they are in equilibrium. I mean that's the initial moles. That's it. There's no mole of it. There's no NH3, and the equilibrium moles are K is saying at equilibrium. Okay, so the last column, the final equilibrium mixture contains 0.3 moles of NH3. So यहाँ पे ना you have 0.3 moles of NH3. So what does that indicate? Okay, you started off with 0 moles, but now you have 0.3. that indicates that 0.3 moles got produced. There must have been a reaction in which these many moles they got produced in the reaction. So if 0.3 moles are getting produced, 2:3, that means what's 2:3? It's probably that means according to the ratio to produce 0.3, 0.45 must have reacted. And 0.15 of N2 must have reacted. ठीक है ये clear है Aiza Rida Heba, is this clear? Shaz,
Yes, sir.
Acha. So this is what's happening. So 3 moles initially, 0.45 reacted. So what do you have at the end? कितना होगा 2.55? And this one is going to be 0.85 moles. Okay, so 0.3. Let me just double check. Looks fine. Everything looks fine. Just let me quickly open a marking scheme as well, just to double check this. So this one we were on which question? I think it was just the first part. So we got the same moles. It's 0.85 and 2.55, but correct up to 3 significant figures because he was using with a question. 1 second. Since we were using the accuracy was up to 3 significant figures, so make sure you use the right number of significant figures. N2 is 0.850, and this other one is 2.55 moles. Now the next thing is calculate the partial pressure of NH3. So you have your pressures now with you. The total pressure that's given is 2 times 10 power 7. So that's the total pressure, 2 times 10 power 7. So how do you find the pressure due to NH3? It's going to be the partial pressure due to NH3 is going to be the mole fraction of NH3. Now the mole fraction of NH3 is 0.3 moles divided by the total moles. So what are the total moles at equilibrium? That's 0.3. Isko add up kar lo. Can somebody tell me, Zahib, Ridaiba, can you tell me what's the total number of moles? 2.85? 3.7?
3.7.
Okay, so you're getting 3.7 moles multiplied by the total pressure. It's mole fraction multiplied by the total pressure, which is given as 2 times 10 power 7. So what do we get? क्या आ रहा है इसका? 16.2 times 10 power 5.
Sir, par 6 है.
वो फिर 1.62 हो जाएगा. Just 1 second, let me just check. नहीं वो तो KP है. हाँ ठीक है. Power 6, it's the same thing. ठीक है, same thing. मतलब यहाँ पे 16.2 लिख दिया, it's 1.62. ठीक है, 10 power 6, which is the same thing. Achha, then you have to calculate the value of Kp. The expression for Kp is NH3 product. NH3 get 2 moles there, so that's squared, and the whole thing will be divided by the pressure of N2 multiplied by the pressure of H2, which is going to be cubed because it's 3 moles there. To try and find, now you have to be, it's a very straightforward question, but you have to be very, very careful with this calculation. It's going to be 0 into 10 power 4. Okay, the second part का answer है. So that's square into is 2.2. You can make sure you use your brackets very carefully on your calculator, okay? And divide by h2 cube, that's 9.62 times 10 power 5, and this is going to be cubed. Iski value, though, what's the value that you're getting for this?
One
One
to 10 power minus 16.
Kitna 1?
into 10 is to power minus
1 into 10 minus 16.
3 significant figures tak karna hai, okay? So just let me just confirm that's 1.00. Okay, so it's going to be 1.0010 10 is power minus 16. Next is कि इसके बाद क्या है? Just a second. So next one is state the units. You have to state the units as well. So I think this was in pascals. So it's basically Pascal squared divided by pascals multiplied by Pascal cubed, which is going to be, खुद ही figure out कर लो, it's going to be pascals minus 2, I think. I think square and 4. It's going to be pascals minus 2. And then he's saying the reaction is repeated with the same starting amounts of nitrogen and hydrogen. The same temperature is used, but the container has a smaller volume. State the effects, if any, of this change on the yield of ammonia and the value of Kp. Now, the first thing is everything is the same temperature, same starting point. Okay? But a smaller volume. What does a smaller volume mean? What effect would that have? पहले तो what
high pressure.
ठीक है, that indicates that because everything is the same, तो अगर आप सिर्फ वॉल्यूम डिक्रीज कर रहे हो, सो आप क्या कर रहे हो, आप हायर प्रेशर पे जा रहे हो, ठीक है? सो यू बेसिकली गोइंग टू अ हायर प्रेशर, एंड इफ यू आर गोइंग टू अ हायर प्रेशर, तो less gas mole side, that is the side that's going to be favored. तो उससे सिर्फ मांगा, बस सिर्फ एक्सप्लेनेशन भी नहीं मांगी, वी जस्ट आस्किंग कि व्हाट हैपेंस टू द यील्ड ऑफ अमोनिया. So less gas mole side forward चला जाएगा, ठीक है? क्योंकि N2, मतलब if you look at the equation, where's the equation? कहाँ गई हमारी? अच्छा, it's over here. So less gas mole side is on the forward side, ठीक है? Because backward में there are 4 moles and forward के अंदर there are 2 moles. So it's going to go in the forward direction. So effect on the yield of ammonia, that effect is कि more ammonia, higher yield, more ammonia. Effect on the value of Kp. क्या होगा? What would be the effect on the value of Kp?
Increase.
क्यों?
क्योंकि प्रोडक्ट ज्यादा हो रहा है ना, तो
नहीं, वो ठीक है. No effect. Remember, there's not going to be any effect. And the reason for that is Kp and Kc, they're only affected by temperature. If you keep the temperature constant,
exactly.
so that means no effect on the value of Kp or Kc. As a next question, this is an ionization energy question. इसका हाँ वही है, तो it's Na. इससे पहले क्या होगा? Na होगा. NaMgAl ऐसा है, और उसके बाद there's going to be Cl and argon. ठीक है? Dips at group 3 and group 6. So this one, explain why there's a general increase in the first ionization energies across the period. So what happens across the period? 2-mark question, 2 points. Across the period, what happens? Why does it become more?
Gets smaller, the radius gets smaller, charge increases.
Charge, कौन सा charge? Nuclear charge, ठीक है? Number of protons, ठीक है? 1 point, number of protons increase. 3 points actually. Same shielding. And distance slightly decreases. So the distance very slightly decreases. As a sketch on the graph, the position of the two elements that come before Mg in the sequence. Before Mg, so Mg से पहले क्या आता है? Na आता है. ठीक है. Na से पहले कौन सा आता है? Where would be the one that would be before Na, which is neon? Neon कहाँ पे होगा?
वो ऊपर होगा, मतलब it will rise up.
ठीक है. But it's going to be really high up. Because that's the previous period. ठीक है. So that's where neon is going to be. अच्छा, और उसके बाद explain why there's a reference to the decrease in first ionization energy. So why is there a dip at AL? What is the explanation for that? It's a 4-mark question, 2 points.
Because that electron in aluminum is actually in the p orbital, while in magnesium it is in the s orbital.
ठीक है. So that's one mark. ठीक है. ये पहला point तो ये लिखोगे in AL. Electron is removed. बल्कि उसके साथ ही लिख लेते हैं. Removed from a higher energy 3p orbital, I think. Which is further away and more shielded. और फिर वो एक उसका भी लिख दो Mg का. While Mg electron is removed from a 3s orbital. orbital, ठीक है, वो लिख दो. अच्छा, फिर उसके बाद क्या कि PNS, उसका क्या लिखोगे? 2 points.
Lone repulsion.
ठीक है, लेकिन उससे पहले बताओगे कि S के अंदर ना इलेक्ट्रॉन इज रिमूव्ड फ्रॉम अ पेयर्ड p subshell या p orbital. मतलब पहले इसमें ऑलवेज ना, मतलब डायरेक्ट वो बात नहीं लिख देनी, पहले वो इलेक्ट्रॉन अरेंजमेंट बताना है. ठीक है. इलेक्ट्रॉन इज मूव फ्रॉम अ पेयर्ड p orbital which has spin pair repulsion, lone pair नहीं. while वो जो दूसरा है ना उसके अंदर the p orbital is singly filled. ठीक है. all of it is half filled, so there is no mutual repulsion. As the next one, the chlorides of elements in the third period have different ways. Chlorides की बात हो रही है, ठीक है, when they are added to water. So I'll just briefly discuss one by one. NaCl क्या करता है water के अंदर? सिर्फ dissolve होता है और कुछ नहीं करता. MgCl2 क्या करता है water के साथ? वो भी mostly dissolve करता है, but it does react a bit with water. How does it react? कि अगर मैं यहाँ पे बनाऊँ कि Mg2+ का चार्ज थोड़ा सा ज्यादा होता है. So what it does is कि it kind of attracts water molecules too strongly. ठीक है, कुछ ज्यादा ही strongly attract करता है. Which is why the H, because of the higher charge, the H might get knocked out and the O might get attracted to it, and some hydrolysis would be possible, but very slight. वो H जो है ना, that would get knocked out and will bond with Cl to form HCl. ठीक है, but very slight hydrolysis. Most of the time it simply dissolves. And when it comes to Al, so the same thing happens. ठीक है, when it comes to Al, pretty much the same thing happens. But now Al is 3+. तो उसके केस में वो जो H knockout हो रहा है ना, that happens very very strongly. ठीक है. और उस केस में द हाइड्रोलिसिस बिकम्स वेरी वेरी स्ट्रॉन्ग, और उसके बाद ना हाइड्रोलिसिस पे स्ट्रॉन्ग ही रहता है, तो there's going to be strong hydrolysis after that. So remember this, NaCl dissolves, MgCl2 also kind of dissolves, थोड़ा सा acid बनता है, very very slightly acidic, around 6.5, that's it. AlCl3 strong hydrolysis, और उसके बाद फिर SiCl4 और sulfur chloride और phosphorus chloride, they all are going to hydrolyze. तो कह रहे हैं कि each chloride, a student investigated L is a white crystalline solid with a melting point of 987 kelvins. So that means it's probably ionic, क्योंकि मसला तो इन दोनों में से कोई है, ठीक है. 987 kelvins NaCl मतलब ionic होगा, क्योंकि उसके बाद ना AlCl3 onwards they become covalent. मतलब AlCl3 is covalent, it dimerizes, it evaporates as well. SiCl4 is also a liquid, और phosphorus तक ही है, PCl3 PCl5, right? So they're also gases, liquids, low boiling points. So the first two are ionic. So it dissolves in water to form an approximately neutral solution. Adding NaOH to an aqueous solution of L produces a white precipitate. So probably the first two, and probably the second one, क्योंकि उससे कहा है कि approximately neutral. So it's probably MgCl2. Y के थोड़ा सा hydrolysis भी होगा ना, तो इसलिए it's approximately neutral. मैंने 6.5 कहा था, so it's approximately neutral. Plus it's also forming a precipitate. Group 1 के जो compounds होते हैं ना, they're all soluble, so they can't form a precipitate. NaCl में NaOH डालोगे, nothing would happen. लेकिन if you add MgCl2 में, MgCl2 is Mg2 plus and Cl minus 1 ions, और उसके साथ जो है NaOH ऐड करोगे तो that's Na plus 1 and OH ions. तो ये सारे ions अगर mix up हो गए ना, तो Mg और OH मिलके ना they would form MgOH2, which is insoluble. तो सारा का सारा वो solution से बाहर निकल आएगा solid बन के, and they would form a precipitate. तो Mg और OH निकल जाएंगे बाहर, solution में क्या रह जाएगा? NaCl, क्योंकि वो soluble है. So that part would remain in the solution, but Mg and OH that would come out of the solution as a precipitate. ठीक है, ये clear है? Hibar, is this clear? Aiza? Ibrar, clear है?
Yes, sir.
अच्छा, उसके बाद M. Now M is kind of having a low boiling point. ठीक है, so it's probably the other three. Sulfur के chlorides are not in your course, so we can ignore that. अच्छा, it's hydrolyzed rapidly by cold water to form a strongly acidic solution of white solid in fumes. White solid कौन बना रहा है? So it's either a rapid hydrolysis. ठीक है, तो silicon chloride, हाँ,
मतलब it has to be SiCl4 which produces misty fume.
so SiCl4 is going to fume. It's going to form SiOH4 or SiO2. Plus water के साथ react it would form fumes of HCl. Or he's saying it's hydrolyzed rapidly. ठीक है, तो to form a strongly acidic solution of white solid and white fumes. I said this also pretty much happens with AlCl3 as well. But the only thing is कि AlCl3 sublimate करता है. It doesn't really have a boiling point. It changes from solid to gas directly. So most likely it's SiCl4. क्योंकि
Okay, what about
AlCl3, हाँ,
what about PCl3? It also
ये
reacts and
कौन सा?
hydrolyzes PCl3
Which one?
or PCl3.
वो तो दो acids बनाता है. It doesn't form a solid precipitate. Phosphoric acid और hydrochloric acid बना देता है. It only forms acids. No precipitate is formed in that case. ठीक है, इन दोनों के reactions जो है ना, they're kind of very similar. इसका बल्कि मैं खाली इसका वो भी चेक करूंगा मार्किंग स्कीम. One second. अच्छा एक तो इसका बॉइलिंग पॉइंट जो है ना वो प्रॉब्ली यहाँ पे मेंशन नहीं है, ठीक है। वाला it sublimates, turns straight from solid to vapor, ठीक है, 180 के ऊपर, doesn't really boil. So that's probably one of the reasons why क्योंकि उसका हाइड्रोलिसिस जो है ना और SiCl4 का हाइड्रोलिसिस they're kind of very similar, ठीक है। उसका भी होता है कि फ्यूम्स बनते हैं, but we covered the reaction of aluminum chloride with water is dramatic. If you drop water onto solid aluminum chloride, you get a violent reaction and produces clouds of HCl. ठीक है, तो यहाँ पे ना AlCl3 and SiCl4 are almost going to have the same reaction. So we're just going to study a bit के क्योंकि यहाँ पे ना the things are very similar. ठीक है, ये भी फ्यूम करता है. There's a violent reaction. ठीक है, pretty much the same reaction, exactly same reaction. Now, so the only difference that's coming, वो जो subtle सा difference दिया हुआ है, that's the melting, the boiling point. ठीक है, अब मैं इसकी मार्किंग स्कीम चेक कर लेता हूँ. वरना otherwise SiCl4 and AlCl3 they pretty much have almost the same reaction with water. तो अब इसका मार्किंग स्कीम चेक कर लेते हैं just to confirm कि हमारा SiCl4 वाला जो hunch है that is that correct or not. तो ठीक है, वो से SiCl4 ही दिया हुआ है, रीजन कोई नहीं दी हुई. अच्छा नहीं, उसे रीजनिंग का है कि लिखो इसकी ना, तो वो आपने फिर रीजनिंग देनी है कैसे, अभी हमने सारी डिस्कशन की है. ठीक है, एक तो वो आयनिक था, फर्स्ट वन MgCl2, it had high melting points, it was ionic, almost neutral solution because there was only partial hydrolysis or very weak hydrolysis. MgOH2 is the white precipitate, ये भी हमने डिस्कस किया था, and they also gave, they probably खाली 2 marks हैं, so any 2 from this. फिर इसका melting boiling point कम था, so that made it was a simple covalent, not the first two. खैर ये d orbitals वाला तो part आप छोड़ दो क्योंकि ये तो A2 का है, so that doesn't really apply to you. Somebody who's done A2 and doing a composite might have knowledge of this, not you guys. अच्छा, forms HCl, तो वो fumes of HCl, white solid तो उसने कैसे O2 है, ठीक है, so you wrote down the equation as well. So any 2 from that. अब वापस आते हैं उसके ऊपर कि ये तो हमने पूरा एक्सप्लेन कर दिया. And you have to give an equation as well, I think. Give equations where appropriate. So the दोनों में ना एक मार्क इक्वेशन का भी था. अच्छा, नेक्स्ट वन, तो ये बस याद रखो, there's a subtle difference. AlCl3 SiCl4 hydrolysis is almost the same except for the fact कि वो AlCl3 boil ही नहीं करता. अच्छा, so you have this, I think this is a primary alcohol, and you have this reaction scheme, और उससे कहे कि reagents और conditions बताओ, reaction 1 2 3 4 5, अच्छा सारों की बताओ, type of reaction भी बताना है. So let's one by one. Okay, halogenoalkanes, they undergo nucleophilic substitution. So this is an SN reaction. ठीक है, the Br could be replaced by Cn -1. ठीक है, that's nucleophilic substitution, or it could be replaced by OH. So that is again an SN reaction, a nucleophilic substitution reaction. OH के साथ substitute करने के लिए you need NaOH aqueous. And the condition that is needed is reflux. अच्छा, उसके लिए reaction number 3 CN के लिए you need NaCN, and that should be ethanolic. And there's going to be reflux as well. As a reaction number 2, this is elimination. क्या आप halogen remove कर देते हो? Elimination happens from one atom Br is lost, and from the next one, the other one, there's H that is lost, and they end up forming an alkene. और इसके लिए NaOH ethanolic use करते हो. And reflux. तो NaOH aqueous use करोगे तो OH substitute कर देगा. अगर if you use NaOH ethanolic, then the Br would be replaced and eliminated, and you'll get an alkene. अच्छा, फिर this is the primary alcohol. Primary alcohol turning into an aldehyde, turning into a carboxylic acid. So how do you turn a primary alcohol into an aldehyde? K2Cr2O7, acidified plus reflux. You could also use KMNO4. ये किया oxidation में, ठीक है? That's obviously oxidation. Aldehyde formed. Aldehyde could be turned into a carboxylic acid. Same reagent. Or there are two more reagents that do the same thing. What are the other two reagents that would oxidize an aldehyde?
Fellings and tolerance.
ठीक है, so Felling and Tollens are going to do the same thing. Nitriles का सिर्फ एक ही reaction अभी तक पड़ा है, वो it turns into a carboxylic acid. How? By hydrolysis, heat with dilute acid. तो nitrile जो है ना, that breaks up into a carboxylic acid, साथ एक NH4+1 भी produce होता है. So we're pretty much done with this. ये table हो गया. Then he's saying कि I think SN2 mechanism draw करो. SN2 mechanism क्या था कि this was a polar bond. तो जो OH-1 था ना, that would come in and that would directly attack the carbon. और Br टूट के अलग हो जाता था. तो say complete the diagram to show the SN2 mechanism. R represents the अच्छा, R represents the CH. Forget that. तो आपने बस पहला step I think draw करना है. बीच में there is a transition state. I don't think that they're asking for the transition state. Transition state क्या होती है कि ये तो final molecule है ना, लेकिन बीच में ना there's a transition state that happens कि you have H and you have एक side से there is R and the Br is breaking off and simultaneously the OH is coming in to join. ठीक है, that's a transition state that is also formed. अच्छा, बाकी अगले पे चले जाते हैं कि define the term structural and name 3 different types of structural isomers. Structural isomers तो O levels का ही है कि same molecular formula, different structural formula. ठीक है, so the molecules having the same molecular formula, same number of atoms, but they have different structural formula. कौन से 3 types के structural isomers होते हैं? और क्या-क्या होते हैं?
Chain isomers, functional isomers, and
अच्छा, ठीक है, so it's chain, functional, कि जिसके अंदर ना you change the functional group. And what's the third one?
position.
हाँ?
Position.
Positional. ठीक है, positional. कि chain के अंदर what you do is कि you carbon की chain को ना आगे पीछे you change it. ठीक है, 3 carbon atoms in a line, 4 carbon atoms in a line, you can sort of branch them out. Functional के अंदर you can change the functional group, like aldehydes and ketones are isomers of each other, carboxylic acid and esters are isomers of each other. Position के अंदर you change some position. अच्छा, फिर वो कह रहे हैं कि there's this molecule 2-methyl propane and is treated with the same reagents. Identify the mechanism. Explain why this reaction proceeds by a different mechanism. So this is a tertiary halogenoalkane. इसका जो mechanism है ना, it's propane, that's 3 carbon atoms, and it's a bromine on the second one and another carbon methyl on the. अच्छा, इसका जो mechanism था ना, that was for a tertiary. The mechanism was कि the OH is not going to come in initially. ठीक है, I mean the OH plays no role whatsoever initially. The Br breaks away on its own. और फिर अगले step में ना there's a carbocation that is formed. ठीक है, there's a carbocation that is formed. The Br-1 has broken away, and the first step में the OH has nothing to do with it. ठीक है, it doesn't even start the reaction. ठीक है, it's not even needed at the start of the reaction. फिर अगले step में ना अचानक OH-1 आ जाता है and the carbocation goes and bonds with the carbocation. So that happens in the next step. So that's the mechanism. So the question is, why is the OH not attacking the carbon over here? The bromine is partial negative, the carbon is partial positive. So why is that not happening? The reason that's not happening is the carbon has a very weak partial positive because it is surrounded by carbon chains and the carbon chains have an electron donating effect. जिसकी वजह से क्या होगा? That the carbon positive charge is not really very strong. And it's because of the same reason the Br breaks away easily. Because the negative Br is not really attracted to the positive. Because the positive charge is not very strong. पिछले वाले के अंदर जो पिछला mechanism draw किया था, the positive charge was very strong, which is why the Br was very strongly attracted to the positive. Which is why the OH had to come in and then it would push the Br away. But not here. The Br is not really attracted to the positive carbon atom. And अगर Br electron लेके चला भी जाएगा तब इसके ऊपर the positive charge is not going to be very strong. So the reason is it's the stable carbocation. ठीक है, explanation क्या होगी कि carbocation produced, you can draw this carbocation is very stable. उनका बता दो कि it has 3 alkyl chains which have electron donating effect. ये बात clear है सारों को?
Yes, sir.
So the carbon has such a weak positive charge that it allows the Br-1 to go away. Okay, which is not possible in SN2 mechanism. तो इसके मार्क्स देख लेते हैं कि और क्या लिखना था इसमें. तो आप बस पॉजिटिव चार्ज डेंसिटी के बारे में एक पॉइंट लिख लो कि or I think it's just 2 marks. ठीक है, 1 mark for the mechanism, so probably 2 points for this. We can just have a quick look at this कि कहाँ पे है. ये तो mechanism है. Where's the ठीक है, 3 alkyl groups, greater inductive effect, alkyl groups we कह रहे कि ठीक है, electron donating effect, that's it, and form the stable carbocation. That's 1 mark for that. ठीक है, या फिर stable intermediate या charge density जो है वो reduced है. ठीक है, so you could, so it's just these 2 points, that's it. चलिए ये फिर कल कंटिन्यू करते हैं. ठीक है,
चलो
from चले, okay, take care, Allah Hafiz.
Allah Hafiz.